Hello there. Today we'll be doing special product lists. Given a list of integers, nums, return a new list such that each element at index I of the new list is the product of all the numbers in the original list except the one at I. Do this without division. Okay. So I think the point about the division part is that you could just sum up every single number and then divide by that current number except if it's 0. I guess if it is 0, then you just replace it. Well, anyways, point is that was one of the solutions. But to do this without division, we can create two lists. So what I mean by that is that suppose we have 1, 2, 3, 4, and 5, and we do a computation. This is 1. 1 times 1 is 1, 2 times 1 is 2, 3 times 2 is 6, and 4 times 6 is 12. So we're going to go multiply everything one way. So we have everything prior to that current number as our multiplication item. And then we'll multiply it the opposite way. So what does that mean? That means we'll multiply this by a previous item, which is 1, and then we keep building up this number, and we have 5 here, and then we multiply that by the next item, which is going to give us 20. 20 times 3 is going to be 60. And last item is going to be a 120 because we're multiplying that by 2. And so this way we have two sets of numbers going each in the opposite direction, multiplying only items up until this point and items up until this point. This all the number items from left to right and right to left. So what does that mean? That means we're multiplying these items one thereafter. So we get a total of 12. Wait a minute, this is 24. My bad. Because 4 times 6 is 24. Right. So with that, we multiply it from the other side. So we have a 5, and then a 20, and then a 30. So we're multiplying everything except for the opposite side. Now we have both sides of the number except the number itself. So if we multiply this number that times this number, then we're multiplying everything before 1 and everything after 1, which gives us 120. Same here. We're multiplying everything before 1, that's where we get the 1, and multiplying everything after the 2, which is where we get 60. Same for this item here, 3. We're multiplying everything before the 3, which is 2, and everything after the 3, which is 20. And we're multiplying everything before the 4, which is going to be 6, and everything after is 6, which is 5. So and so on and so forth. And the last one, we're multiplying everything before the 5, which is 24, and then everything after 5, which is 1. And then we get our total, which is 120, 60, 40, and 30, and 24, giving us the correct output. So let's do this, and I'm going to start with a less optimal way of doing this. Then I'm going to do a more optimal solution with less space. Okay, so first of all, let's create. Let's just comment this out. So first things first, let's create a left and a right, which is equal to an empty array that we can create, which is basically this is going to be our left and this is going to be our right. So now we're gonna create a left product and a right product, which is starting at 1. We're starting at 1 on both sides. So then we're gonna do for n and m in range, in zip of the num and reversed num. That way we get both sides. We could actually not use reverse and just use nums and nums. Point. Ah, there we go. That's it. That goes in the reverse direction. I'm sure that's how it works. Okay, so now we can add these items in to our left and right. So left dot append n, and right dot append m. So we're going in both ways. Now that we have done this, we need wait a minute. This is not the product. My bad. L and R. L times equals n, and R times equals m. All right, we multiply both sides now. Now that that's done, we can now combine these two. So return. We're gonna do for I in zip of nums. I mean left, and reversed right. The reason why we need to reverse the right is because we're not going against the grain here. We're flipping it around so we can multiply the same spot every single time. Because at this point we appended everything in the opposite order. Anyways, I think you'll see what I mean. So now we multiply L and R. We multiply the left and the right on both sides, and we return the correct answer. Whoa, what happened? Not scriptable. What does that mean? Yeah, what line is this? Reverse type, it's not subscriptable. I see. Submit. And we have a pretty solid answer here. But we can go one step further and reduce the amount of space used to O of n rather than 2n. And this involves going through our loop twice instead of once. Okay. So the first thing we're going to do is get the length of the nums, because we're going to be using the indexes of the item and using one array called output. So for I in range of n, we're going to go this through this out. We're going to set up the output by appending the product from the left to the right first. So product is going to multiply after the appending of I. Then afterwards, we reset the product to equal 1. And now we're going to go in the opposite direction of the array by moving in the negative direction. And the output of I is now going to be equal to the output of I times the product. This will save us a time for doing the loop, extra time, like in this one, where we have to redo the looping. So product times equal nums afterwards. So we're doing everything in one step, and now we can return the output. This should be a little faster in terms of time complexity and in terms of space complexity. This is more efficient than the previous solution, but the previous solution was more visually, I guess, explanatory. And that is all for special product lists. Thank you very much for watching. I hope you enjoyed the video. If you have any questions, like and put some comments in the comment section. If you enjoyed the video, like and subscribe. And if you want more videos, check the link in the description below. Thank you very much, and I'll see you in the next one.